Dear audience, welcome back to another episode of the FrontAg Nexus podcast series. I'm Panagiotis Dalagiannis, Communications Manager at Reframe Food, the organization helping to shape the dialogue around this important initiative. Today, we're taking another look at the changing landscape of smart agriculture across the Mediterranean, with a special focus on countries at the forefront of climate challenges, like Italy, Morocco, Tunisia, Turkey, Israel, and Jordan. With water becoming scarcer and farming conditions growing tougher, how can we rethink agricultural practices to build more resilient systems? To explore this, we're joined by Professor Amit Gross from Ben-Gurion University of the Negev, a partner in the FrontAg Nexus project. Welcome, Amit.
Hey, hello, and thanks for having me for this podcast.
So, to begin, Amit, could you tell us a bit about your work at BGU and how it connects with the objectives of the FrontAg Nexus project?
Well, here at Ben-Gurion University, my research is dedicated to creating sustainable systems for managing water, waste, and agriculture, and particularly in dry regions like the Negev desert. So we focus on closing resource loops, recovering nutrients, reusing treated wastewater, converting waste into energy, while ensuring environmental protection. And this is directly connects with the FrontAg Nexus project, which aims to develop frontier agriculture systems that can thrive under resource scarcity. So truly our work provides practical models and tested technologies that FrontAg can use to promote sustainable agriculture in arid region or semi-arid regions, basically anywhere around the world, and specifically in the Mediterranean.
So I see that your expertise directly aligns with the project's objectives. And now let's learn a bit more about the people behind this effort, Amit. Could you briefly introduce your team and tell us how they've been involved in the FrontAg Nexus project?
Yeah, so first, it's almost goes without saying, it's a team effort. It's not a one person mission. It's impossible, I would say. And our team at BGU is a multidisciplinary group that brings together expertise on environmental engineering, on agronomy, microbiology, and modeling. And we work across the full development chain. So that's what we're aiming at. Basically, from design technology, the design technologies and testing them in the lab and later in the field, and assisting the environmental and economic performance, or testing the environmental and economic performance. Specifically within the FrontAg Nexus, we have Dr. Zezou, who is a postdoctorate with immense experience in aquaponics and aquaculture, both from China and Wageningen, the Netherlands, and from here, from Ben-Gurion University, from our studies. And he's leading the pilot, and together with my PhD student, Hiram Karanja from Kenya, and two master students, or El Rahamim and Robel from Ethiopia. And altogether, it's actually a multicultural group, which makes it, very interesting. And last but not least, of course, is Professor Osnat Gilor, who is leading the microbiological aspects of this project. Altogether, we operate a novel indoor aquaponic system for the production of barramundi fish and greens like lettuce and other basil, with near zero waste, by recovering and reusing very efficiently the water, the energy, and the nutrients, which are all found in what traditionally would be considered waste, such as the fish sludge or the plant inedible parts of the plants, etc. And all of which are typically wasted from these systems, but we're reusing them. And this is a clearly collaborative environment with all these skills, which makes it which help us to tackle these complex problems very interestingly and creatively, I would say.
So as you mentioned, definitely it's not a one-man show, and it seems like you have a really strong team combining different expertise, which is essential when addressing such complex challenges. And speaking of those, Amit, of challenges, let's turn to a crucial issue for agriculture in dry regions. Saline water is becoming more important in agriculture, especially in dry areas. What are the main benefits and challenges of using it in a place like Negev?
So this is an interesting question because thank you for that, because saline water is unique water. Why is it unique? Because it's very different than when we say water, we often think about fresh water, which is of fairly known quality, or of marine water, seawater, which also is of fairly uniform and known quality. But when we say saline water, we don't know exactly what it is. The salinity may vary dramatically, but not only the salinity itself, the ion composition may vary. When we're talking about plants and fish, it is impact, the composition is very important. We need to have the right ions, not only the right salinity. So this is a main challenge. And I'll speak about that in a minute. But the benefit is that we have a lot of it relatively in the deserts. So if we manage to use it, we can save on scarce fresh water, and we can utilize agriculture in an area where water is not abundant commodity. So we try to basically understand the quality of this saline water and choose the right fish, the right plants that can be salt tolerant, or be able to do well in the ion composition that we have in the saline water, and we have to adjust all these things in order to improve or optimize crop production. And that's why it's interesting, it's challenging, but it's working well, and we're very happy about that.
It's super impressive how you can combine those different systems in one and have such results, Amit. And your team also has been exploring cutting-edge solutions like LED systems. And I would like now to delve into that. Could you describe us how these systems function and what makes them relevant for sustainable food production?
Yeah, so what we are doing is we decided to work in an indoor aquaponic environment rather than outside, and that helps us to have an independent system. So the conditions outside are less important or not important at all to the success of this process. By using LED light, we manage to harness specific light spectra to help the plant growth. And what we're also doing is we just now put the solar harvester, and we harvest outside light with optical fiber into the hydroponic, into the plant chambers. And the combination of of light from the outside obviously save energy because we bring light and we don't need to use LED all the time. And it brings different wavelengths that are not found in the LED. And the combination, or we try to get the combination that will make efficient growth, again, successfully. We also being able, by doing that, to extend the light period of a day and basically grow plants if it was only outside, we are limited by the light outside. But if we have external light source, then we can grow it for longer and shorten the amount of time that we need to grow the plants, and basically get more food per unit of time and help food security. So by doing this combination, I think that we're again trying to be very efficient in the production and do it independently of the harsh environmental conditions that may be found in the desert.
So we're talking about a combination of new technologies like LED with resource management.
Absolutely, yes. This is exactly right.
It's truly promising, Amit. So to wrap up, I would like to hear from you your personal reflection based on your experience in the field. If you had to share one key takeaway from with frontier agriculture in arid regions, what would it be?
So I guess there are several, but I would say if you want me to give a key, I would think that a success in frontier agriculture does not come from copying traditional methods, but it comes from redesigning systems to match the environment, actually, which is really a unique and a different approach. And specifically in arid regions, we need to treat every resource. In this case, it's water, it's nutrients, and it's the energy, which are very precious and interconnected. And by closing these loops, we integrating technologies and adapting the flexibility to changing conditions, we can build resilient and productive agricultural systems, even where conditions are extreme. And that can be in many environments. It can be in the desert, but it can also be in a refugee camp where land is scarce, not only water and resources, and possibly in the moon one day. So basically, it's this kind of approach that help us to design this system for food security and sustainability and efficiency, which is all related to the FrontAg Nexus or FrontAg project, and all correlates with the other teams. So this is also a very nice environment where each group from the different countries, contribute something to the project, and together it comes to be an holistic approach.
And as I see it, this is also a sustainability plan of the FrontAg Nexus project, because all these takeaways can be implemented and have impact after the 4 years of the project and after the conclusion of the project, which is really important, Amit. Thank you very much for sharing your insights and for the discussion that we had today.
Yeah, thank you very much for having me here. And yeah, I really cross fingers that it will be materialized and will not stay in podcasts and in the labs or in the pilots, but it will be materialized in the real world and help our society. Yeah, thanks.
And thank you to our audience for tuning in. Stay with us for more engaging discussions, and don't forget to follow us on social media and subscribe to our newsletter for the latest updates. Until our next podcast, remember to save water and think sustainably.